Okay, so this is a bit of a set of notes on how to take inferences when comparing two means. Okay, so um, if you meet the conditions that we would set forth, which would be, um, well, if you're, so what are we talking about here? We're talking about we have like a sampling distribution of two sample means, right? How are these distributed, right? So these things are, so long as I'm taking them from a random sample, right, that are independent, um, and I have met the 10% condition, and I have also met either that the original populations that these samples are coming from are either normally distributed or the samples are sufficiently large, which means that they both have to be bigger than 30. Now, like one can come from a normally distributed sample and the other one can come from a sample larger than 30. It's like you can mix and match there. So if I've met those conditions, I get a normal distribution that's centered around the population means, right? The difference of the population means. But remember that the standard deviations here, you have to break back to the variance, right? So the standard deviations here are going to be the standard deviation from the first population squared over n1 plus the standard deviation of the second population squared over n2. So that's like the variance plus the variance over the taking the square root of all of that, right? So that's how the sampling distribution sets up. So if I meet those same conditions for inference, right, I can start to build a confidence interval. Now the confidence interval here is a little different, right? So you have to remember that we're working on a t distribution, right? So the confidence interval is going to be working with a t distribution, and you have a degree of freedom situation here. Now, when you're working this by hand, you would say that you have the smaller number of degrees of freedom of either n minus 1 minus 1 or n sub 1 minus 1 or n sub 2 minus 1. That's like the easiest way to do this by hand. It's a more conservative estimate. You pick the smaller of those two. This is not what the calculator does. The calculator is going to come up with a slightly larger number of degrees of freedom, and it does this through like a really complex calculation that you don't need to know, but ultimately the AP exam will accept either the conservative answer here or the more complex one. Okay, so the confidence interval then is going to be x bar sub 1 minus x bar sub 2, so it's the point estimate, plus or minus, and then we get a t star, right? So that t star is determined by my confidence level, right? And also my degrees of freedom, which are either going to be n sub 1 minus 1 or n sub 2 minus 1, so the more conservative of the two, right? And then times the standard error, which is going to be the standard deviation of 1 squared over n sub 1 plus the standard deviation of sample 2 squared over n sub 2, which are like the sample variances, and then sum them and take the square root. Okay, so let's look at like how would I play this out with the calculator, right? So let's take a minute here. Okay, so let me get that out of there. So I just dropped in a data set in here where like you've done some sort of reality. I think this is about blood pressure, and the question is just like, does taking calcium change somebody's blood pressure any different than placebo, right? So we've got two different samples here. We're going to put one in L1, we're going to put the other one in L2, and then we're going to come up for a confidence interval for the difference between those samples. So let me do a little bit of video magic here, put all the data into the calculator. Okay, so you can see I loaded all the data into L1 and L2. You can notice that the two sample sizes are not the same. We're going to make the assumption that these are coming from normally distributed populations because we definitely don't have enough data there to take in the central limit theorem. So what I'm going to do here is have the calculator generate the confidence interval. So I'm going to go stat tests. We're using the t distribution. We're using two proportions. So I want a two sample t interval, right? That's what I want there. I'm going to take this from the data from list 1 and list 2. Both the frequencies I want to have as 1. I want to have a 0.95. And for the AP exam, you're always going to consider the data to be non-pooled. So we're going to consider this as to not pool, and we're going to calculate. And there is my interval. Okay, so we're going to say that the true difference between the two means has, I'm 95% confident that we are somewhere between negative 1.712 and 12.257. That's pretty broad, but the one thing that's really notable here is that it's negative on one side, positive on the other, so we cannot rule out that, in fact, the placebo effect is happening here, right? That there is no real difference between placebo and calcium. So if you take a look here, the degrees of freedom are like 15.59, which is way higher than either 9 or 10, right? Well, 9 that we would get by the more conservative estimate, okay? So the calculator is able to kind of do this with a little bit more precision than what we are accustomed to. Okay, so, but again, the AP exam will accept it as by hand. Following forth from this, let's say I want to conduct a significance test. So remember, I need the two hypotheses. So the H null here is going to be that mean 1 minus mean 2 will be 0. The alternate can be any form of the difference. What I would like to see is hopefully that calcium is lowering my blood pressure, so we'll say that the alternate is that it is less than 0, right? And we'll see what happens. Like, we'll see if calcium is actually lowering my blood pressure here. I have a sincere doubt that that's the case given this data, but let's go after it, right? So I go in and I grab stat, and now I'm going to do a 2 sample t-test, right? 2 sample t-test. Okay, and I have my data is in L1 and L2. My frequencies are 1 and 1. I'm going to do a left-hand test. I say that my data is not pooled. And I'm going to go ahead and, you guys seem to like the draw one, so I'll go with the draw. And here is my hump. Okay, so this is like way definitely failing, right? Because, I mean, ultimately, if you think about what's going on here, like, I'm over here when I'm trying to test less than 0, right? My p-value is extremely high, 0.9356. Well, like, what's making that thing so high is like the 18 and the 17 in my data set, right? Everything almost, these are like really high positive numbers, right? So in the end, this really high p-value, right? So like p was like something like 0.98, right? Which is like way bigger than any alpha I should imagine, so I should be failing to reject my H null here, right? Which means that it is really pretty clear that the calcium supplement is not lowering, well, I shouldn't say that, because it could be. I should be suggesting that I do not have, there we go, I do not have strong evidence to support that calcium is lowering my blood pressure. Okay, so there you go. It's a quick little overview of 2 sample t testing, and we'll go from there. Thank you.